Okay, so hello everybody. Can you guys hear me okay? Okay, I got a few yeses. That's cool. You might notice that the audio quality this time is slightly better than normal because I'm using a USB mic. So we'll just use this problem as our warm-up. So this problem says, in how many ways can a dog breeder separate his 10 puppies into a group of 4 and a group of 6 if he must keep 2 of his puppies, Biter and Nipper, separate? So I'll let you guys think about that problem as more people start to come in. It's slightly more than 4 ways, just slightly, as in a lot more than 4 ways. But keep in mind that all of the 10 puppies are different. So if you have, for example, so if you, for example, have Biter in this group and Nipper in this group, let's say this is the group of 4 and this is the group of 6. You could have 3 other dogs in that group and 5 other dogs in that group. So if you had like dog A here, dog B here, dog C here, you could also put them anywhere in this group. So there's actually a lot more ways. It's more than 15. It's a pretty big number. Okay, so let's get started here. Okay, so we can approach this problem with casework. So keep in mind that he must keep Biter and Nipper separate. So that means if Biter is in group 1, then Nipper has to be in group 2. So case 1. Biter, B, is in the 4 group, or the group of 4. And case 2 is when Biter is in the 6 group, or the group of 6. So for case 1, So in case 1, if Biter is in the 4 group, then that means Nipper has to be in the group with 6. So besides Biter, there are 3 other places you could put dogs. And besides Nipper, there are 5 places that you could put dogs. So now you have 8 pups left. And you have to put them either here or here. So can you guys figure it out from here? keep in mind that these are groups of puppies. They're not ordered lines, which means that, for example, if I had A here, B here, and C here, it would be no different from having B here, C here, and A here. So for case 1, the number of ways to arrange it is 8 choose 3. Since you have 8 pups left, and you just choose 3 of them, A, B, and C, to go in the group with Biter. And by default, every single other puppy has to go with Nipper. Okay, so case 2. Biter is in the 6th group, which means Biter and 5 other dogs and Nipper and 3 other dogs. So can you guys figure out what we do here? So remember, we have 8 pups here, just as in case 1. And you'll start to notice that case 1 and case 2 actually look a lot similar. Like there's virtually no difference between case 1 and case 2. We just switched where the B and the N are. So just like in case 1, in case 2, we also have 8 choose 3 ways. Because there are 8 puppies, and we could choose to put them, we could choose three to put them here, and everyone else would by default go with Biter. And note that this would be the same thing as choosing 8 choose 5, because we could choose 8 puppies to fill in the blanks here, and the other 3 by default go to Nipper. So then therefore the answer is the sum of the 2 cases, which is 8 choose 3 plus 8 choose 3. And that gives you 112. So I saw a few people got that, so that's correct. You have to be careful with these types of problems because sometimes you might want to just add 2 cases together, but sometimes case 1 and case 2 actually might overlap, and you would have to subtract where they overlap. So like, for example, if there was a certain type of way that you counted here, and you also counted here, you would accidentally be counting one over time, so you would have to subtract it. Okay, so next problem. So today we're mainly going to be going over Pascal's triangle. So some of you probably don't know what Pascal's triangle is. So, Pascal's the name of a mathematician who lived a long time ago. His name was, I think, Blaise Pascal. And he came up with this triangle. So the way this triangle works is it's a triangle of numbers. So in the first row, we have 1. And the second row, we have 2 ones. And you'll see that the entire outside of the triangle is all 1s. So that's kind of the basis of the triangle. And inside of the triangle, what we have is 1 plus 1 gives us 2. 1 plus 2 gives us 3. 2 plus 1 gives us 3. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4, and so on. So you'll see that every 2 numbers add up to the number below it. And there's a lot of patterns that you can find in a triangle like this, and we're going to go over some of them. So there's another way you could look at this triangle. So last time we learned about combinations, and we learned that n choose k is the number of ways to choose k objects from a group of n objects. And that is equal to n factorial divided by k factorial times n minus k factorial. So this should be review. We went over this last time. But you'll find that the first row of the triangle is 0 choose 0. The second row of the triangle is 1 choose 0, comma 1 choose 1. And the third row of the triangle is 2 choose 0, comma 2 choose 1, comma 2 choose 2. So you guys are probably finding a pattern here. And like, for example, we start at the 0th row and then go to the first row and then the second row. And basically, let's say we go down to this row. So this would be 0, 1, 2, 3, 4. This would be the fourth row. So the first number we can predict by using 4 choose 0. The second number, which is 4 choose 1. The third number, which is 6, is 4 choose 2, and so on. So you can see that if we use combinations, we can basically predict every single number in this triangle. So does anyone have any questions? Okay, great. So let's go over some patterns. So on the next few slides, basically what I have is a list of some patterns that you can find in Pascal's triangle. And what I want you guys to do is to try to see if you can spot some of them or even prove them. So the first pattern I have here is n choose k is equal to n choose n minus k. So can you guys find some examples of this in Pascal's triangle? Okay, I found one person. He said the ends of row 2. So just to be clear, we're calling this row, we're calling this row 0, this row 1, and this row 2. So this number is equal to this number. And similarly, 2 choose 0. The number of ways to choose 0 objects from a group of 2 is equal to the number of ways to choose 2 objects from the group of 2. So you have to be careful when you're trying to use this to prove what you find in general, because knowing this fact doesn't necessarily prove this. So can you guys find some way to prove n choose k is equal to n choose n minus k? You can try using a counting argument. Well, n minus k is just what I want you guys to prove. So if I gave you guys a number n, any number n, and any integer k that is less than the integer n, then this will always hold true. So we're trying to prove that. Yes, 2 choose 0 equals 2 choose 2 is an example of this, but can you guys prove this in general? Yes, there is a way that you can use the algebraic definition. So, for example, n choose k is equal to n factorial over k factorial times n minus k factorial. And n choose n minus k is equal to n factorial divided by n minus k factorial times n minus k. Okay, this is going off the screen, but factorial. Let me rewrite that. So similarly, n choose n minus k by the definition of a combination is equal to n factorial divided by n minus k factorial times n, then minus that n minus k, and then factorial. So if you guys will notice, what is n minus and then in parentheses n minus k? So basically, what is this term right here? Right, so this is exactly k. So this simplifies to k. And so this, basically what this gives you is k factorial. And then what do you notice is the same? Well, these two, here and here, they are exactly the same. And since these are equal to n choose k and n choose n minus k, then we know that this is equal to this. So what we've done is we've proven it. So this is an algebraic argument. A counting argument of this would be to say, okay, so if I have a group of n people and I choose k of them, that would be the same as having a group of n people and then choosing the people not to have, right? So let's say you have 5 people in your class, 5 students, and your teacher asked you, how many ways are there to pick 3 of them to, for example, go to the principal's office? Well, how many ways would that be? Well, that would just be 5 choose 3, which is equal to 10. But another way to count that would be to say, okay, we have a class of 5 students. What if I picked 2 of them to not go to the principal's office? Then everybody else by default has to go to the principal's office. And this is also 10. So if you choose what you don't want, then that's the same thing as choosing what you want. It gives the exact same number. So that's another way you could prove this. Someone asked what grade level math is this? It's kind of hard to say because most school systems don't really teach combinatorics. This is like contest math, and this is like AMC 8 level kind of math you would find on the AMC 8. I know for a fact that my school teaches like a combo course for and to like high schoolers, so it varies a lot. So there's not really necessarily a grade level associated with this, but I'm sure many of you can are capable of understanding this. Okay, let's go on to the next problem. Okay, so this is a similar thing, except we're trying to prove that n choose k is equal to n minus 1 choose k minus 1 plus n minus 1 choose k. So trying to find an example in Pascal's triangle. Someone asked row 8. What about row 8? Well, I mean, well, the answer is actually everywhere, but can you find 3 numbers that satisfy the relationship that's given? So can you find one number in the triangle that's equal to another number in the triangle plus even another number in the triangle? I'll give you a hint. The 3 numbers can be in different rows. They're actually in 2 rows. So basically, 2 numbers in one row add up to the number below it. This is basically what this equation says. So for example, 5 plus 10 is 15. And 21 plus 7 is 28. That's what this equation says. Someone said that we could solve this algebraically. Generally, you don't want to do that. It might have worked for the last question because it was a very simple equation, but when the equations get complicated, there's going to be a lot of hard algebra. And it's often much easier to solve it combinatorically. Someone asked that we do that. So first I'll show you in Pascal's triangle. So let's say we had 5 choose 1. This equation tells us that if n equals 5 and k equals 1, then this would be equal to 4 choose 0 plus 4 choose 1, right? And if we simplify this, we get 5 equals 4 choose 0 is 1, 4 choose 1 is 4. And this equation right here, 5 equals 1 plus 4, is obviously true. But if we look in Pascal's triangle, we see 1 plus 4 is 5. So there's an example right there. And basically for any integer n we plug in and any integer k that's less than that, we can always find something in this triangle. So now I'm going to ask you guys to prove it with a combinatorial argument. So try to do what we did for the last problem and consider choosing groups of people from bigger groups of people. Do you guys need a hint? Someone's spamming white spaces in the chat. Please don't do that. Okay, so basically, a hint would be, let's say we have a group class full of, sorry, let's say we have a class full of N students. Okay, and we want to choose K people to go to the principal's office, right? So, and let's look at a very specific person. Let's say we have this student named Bob in the class, and we're trying to decide whether or not he should be sent to the principal's office, right? So one of these cases, n-1 choose k-1, and n-1 choose k. One of the cases is if we send Bob to the principal's office, and one of the cases is if we don't send Bob to the principal's office. So can you guys figure it out now? We're running a bit out of time here, so let's go ahead and do this. So let's look at this boxed combination first. What is n-1 choose k-1 in the context of the problem? So can anyone tell me what n-1 choose k-1 means? So someone said students -1 choose chosen students -1. So that is correct. That means that out of a group of n-1 students, we're choosing a group of k-1 of them. So what could that group of n-1 students be? Well, where are we getting the 1 from? Bob. So that means that out of everyone except for Bob, we're choosing K students except for Bob. So what this means that is that we have already chosen Bob to go to the principal's office. And out of the rest of the people in the class, out of the other n-1 people in the class, we're trying to choose k-1 more students to join Bob in the principal's office. Does everyone get that? Okay, good. So can someone explain what n-1 choose k means? Think about the other case. So in the first case, we chose Bob. What happens in the second case? Right, without Bob. So what this means is that out of everyone in the class except for Bob, which is n-1 students, we have to choose k students to go to the principal's office. So since we have to choose k, that means we have not chosen Bob. So Bob is already out of the picture. We've already decided that Bob is not going to the principal's office because he was such a good student. And what we're doing instead is we're choosing the students to go to the principal's office besides Bob. So the first case is the number of ways to choose case students if Bob is part of it. And the second case is the number of ways to choose case students if Bob is not part of it. And since Bob can either be part of the group or not part of the group, together they add up to the number of ways to just choose case students from the class of n people to go to the principal's office. So does that make sense? Okay, great. We have 5 minutes, so let's try to hurry and do another problem here. Okay, so we have this problem now. So can you guys find an example in the triangle of this? This is actually easier because here you have to look at the entire row of the triangle. So someone said row 9, probably because that person wants me to add up all the numbers in row 9, but here's row 9. Hang on. Here's row 9. Okay, so basically what this says is, since we chose row 9, n equals to 9. So this becomes 9 choose 0 plus 9 choose 1 plus 9 choose 2 all the way to 9 choose 9. So can someone tell me what this means in the triangle? Like, what does 9 choose 0 all the way to 9 choose 9 mean? Right, adding every number in the row, that's exactly right. So this number is 9 choose 0, this number is 9 choose 1, this number is 9 choose 2, dot, 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 all the way to this number is 9 choose 9. So what we're doing when we're adding this thing is we're actually adding all the numbers in this row. And if someone has a calculator open, can they actually add every single number in this row? Yes, I saw 512. So all the numbers added here equals 512. But what do you know? 512 just happens to be 2 to the 9th power. Whoosh, it's magic. So that's an example of this equation. And can someone try to prove it in terms of grouping people together? Yeah, exactly. So row 0 is 2 to the 0 because 0 choose 0 equals 2 to the 0. So can someone try to prove this in terms of grouping people? We're running a little low on time, so if someone doesn't get it within the next 30 seconds, I'll start discussing. Okay, so one example would be if we have a group of n students, and let's say we want to choose any number of them to go to the principal's office, right? Then we could either send 0 students to the principal's office, and the number of ways to do that is n choose 0. We can choose 1 student to go to the principal's office, and the number of ways is n choose 1. We could choose 2 students to go to the principal's office, or n choose 2, all the way to choosing all of the students to go to the principal's office, which is n choose n. That's a very naughty class. But what is that equal to? Well, let's say we had all of these n students in a line, person A, person B, person C, person D, etc. And instead of doing this, we chose whether or not they went to the principal's office. So there's A either goes or not goes, B either goes or not goes, and dot, dot, dot. So that's actually equal to 2 to the n. Okay, so we have less than 1 minute. So thank you guys for joining, and class is over. So I'll see you guys next time. Bye, guys.